A compressed air brake system is a very common type of service brake used on heavy goods vehicles and large commercial vehicles. Instead of hydraulic fluid, it uses compressed air to transmit the driver's braking demand to the wheels. The brake pedal is a valve that meters air from reservoirs into the brake system. Air brakes are powerful, reliable, and include safety features that keep brakes working even if a minor fault occurs. For Level 5 students, understanding air brakes is essential for safety and roadworthiness inspections. We will explain the system step by step, using simple language focused on practical workshop skills. Think of it as a journey. Air is compressed, cleaned, stored, sent on command to the wheels, creates friction, and brings a heavy vehicle to a controlled stop. By the end, you will recognize parts, trace airflow, perform simple tests, and approach any air brake system with confidence. The journey starts at the air compressor, driven by the engine by belt or gear, drawing air through a filter and compressing it to roughly 120–140 psi. Compressed air is hot and can carry moisture and oil. Water can freeze and block lines. Oil damages seals and diaphragms. An air dryer cools the air and uses desiccant to remove moisture and oil vapor, then purges contaminants automatically at max pressure. Clean, dry air fills strong reservoirs, usually primary and secondary tanks. This split system adds redundancy in case of a major leak. Check valves prevent backflow. The governor maintains pressure. Cuts out the compressor around 125 psi, then cuts in near 100 psi as pressure drops. This cycle keeps the system charged and ready without overpressurizing tanks or overworking the compressor. The control circuit lets the driver command braking. The brake pedal is a dual-circuit foot valve that meters air to front and rear circuits. The further the pedal is pressed, the more air flows, increasing braking force. This is called metering. If the primary circuit fails, the secondary still works. Dual gauges show both pressures to the driver. On tractor-trailers, the foot valve also feeds the trailer control valve. Quick-release valves vent used air near the chambers for faster release. When the driver lifts off, the foot valve closes the supply and opens exhaust to atmosphere, so line and chamber pressure drop to zero quickly. Fast release prevents dragging, improves control, and creates the familiar air hiss when heavy vehicles stop and move off. In a service brake chamber, compressed air pushes a diaphragm, driving a push rod outward with force proportional to line pressure. The push rod turns a slack adjuster, a lever on the splined S-cam shaft, multiplying force and rotating the cam. Cam lobes spread the shoes so linings press the drum, creating friction torque that slows and stops the wheel. Excessive pushrod stroke from worn linings or misadjustment causes slow application and reduced braking. Automatic slack adjusters take up wear but must be inspected. Pushrod travel is typically within specified limits, often less than 2 inches. On release, strong return springs retract the pushrod and shoes to prevent drag, heat, and premature wear. Parking and emergency functions use combination chambers, a service section and a powerful spring section held compressed by about 60 psi or more. Lose air, and the spring expands to apply the brakes. That same spring applied air-released principle holds the vehicle when parked. The yellow parking valve vents air when pulled to engage springs. Pushing it sends air to compress springs and release the brakes. Long before spring brakes apply around 20–45 psi, a warning light and buzzer alert the driver below about 60 psi to pull over safely. Under supervision, chalk wheels charge the system, apply the foot brake, listen for leaks, and verify low air warnings and parking brake pop-out during bleed down. Water in tanks causes corrosion and can freeze lines, often due to a failing air dryer. Drain tanks daily. Low pressure may come from a worn compressor or a malfunctioning governor. Most often it is leaks. Check fittings, hoses, and diaphragms. Use soapy water to spot bubbles. Over-adjustment causes drag and heat. Under-adjustment causes excessive travel and weak braking. Push rods must move smoothly and return fully when the pedal is released. Checklist: 1. Chalk wheels. 2. Build to cutout, 120 130 psi. 3. Confirm low air light and buzzer around 60 psi. 4. Verify parking valve pops at 20-45 psi. 5. Hold foot leak test, no more than 4 psi drop in 1 minute on a rigid truck. 6. Check slack adjusters and push rod travel, within limits, typically under 2 inches. 7. Drain all tanks and check for moisture or oil.